Hello and welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today I want to just do a walkthrough on one of my blog that I wrote around building microservices on AWS. We can use Lambda versus ECS Fargate. And in these two options, we have three different flavors that I want to cover. Let's cover at a very high level what Lambda-based microservice will look like. You can look at this picture where you have a client. The client makes a call to load some website, which is behind the scene. In this case, it is a browser and somebody is on a browser browsing a page. The page makes a request to an API. That request lands into an Route 53 on AWS, which resolves to a DNS within AWS. That is an API gateway for a given region in which the route has moved this request to. If it is an active-active, it may go to region 1 or region 2 based on active-active configuration. If it is active-passive, which means it is going to region 1 always until there is a disaster and you want to move it to region 2. So in this case, let's think like this is a single region setup. Route 53 sends it to an API gateway. API gateway will then use the ACM certificate. The step 3 over here is a Lambda authorizer. Lambda authorizer is basically an interceptor in the middle. It's a common Lambda code that you can have for all the calls that comes through API gateway. The Lambda authorizer can perform things like it can verify whether the token is valid or not. If the token is not valid, a deny policy can be generated for that particular endpoint. Usually what happens is if there is a first request that lands in, and if you have multiple endpoints being exposed by a single service, which is generally not the idea when you are doing a Lambda-based API, you would like to have one single endpoint exposed by a single Lambda. But in case you're doing so, the Lambda authorizer is going to give a allow and deny policy for all the endpoints hosted by that single API. If the Lambda authorizer provides a allow policy for that particular endpoint, the next step triggers, which means the actual Lambda code. If you're running a Spring Boot application, which has multiple endpoints hosted in the single Lambda, that controller within the Spring Boot application will receive the invocation from the API gateway. Once the invocation happens, the Lambda kicks in where the real code is, and the Lambda basically uses the roles and policies that you have assigned to the Lambda to talk to databases, whether it is a SQL or NoSQL database. Once that information either is persisted or fetched, whatever the operation it is, the response is returned. And the information is also logged into CloudWatch for observability. And you can even enable X-ray that can basically give you hops of various function calling within the whole stack. At this point, Lambda is able to return your response, and then that response is sent by an HTTP response to the client. This is at a very high level how a Lambda-based microservice is going to work. Usually, I have seen building these Lambda-based microservices with a single Lambda having all the endpoints, but the preferred way will be to have one endpoint in a single Lambda so that you can scale each endpoint differently. Let's move on to the second service, which is the ECS Fargate-based service. I'll have to scroll a bit just to show you the overall diagram. It is not fitting into the screen. The starting point is same. There is a user with the browser making an HTTP request to your Route 53 in AWS Cloud. Once the request reaches Route 53, Route 53 resolves it to the application load balancer. In this case, we are using application load balancer. There is no API gateway. So the application load balancer can be in region 1 or region 2, depending upon your setup again, your active passive or active active setup. Now, given the request reaching ALB, ALB will then route the traffic to the Fargate task. If you are having a service running, the service can scale the task. So there is a Fargate service that you can have. In this case, I'm just showing you that there are one to many tasks in Fargate. And then these tasks are again using IAM role and policies to perform any kind of invocation that it needs, whether they are talking to one service or many services. All those have to be defined by the policy in this and assigned to the task so that they can make requests to databases where they need to have the access. If we have to have something like a central task that can perform your token validation, your intent validation, again, you can host a library or a task like this, which is performing something that was done in a Lambda authorizer, similar to the API gateway setup. Over here again, this can just say allow or deny, but this will not be a policy. It will be straight allow or deny based on the investigation around whether the token is valid or not, whether the intent is valid or not. And then this information can also be logged in CloudWatch along with the task to the same logging to the CloudWatch. Similarly, if it is allowed, it is again using the same policies that are assigned to the task to talk to other services, like if there is a NoSQL database or a SQL database like DynamoDB, PostgreSQL, any kind of Aurora RDS, even Redis. You have those kind of databases and you need to talk to them. The policy should allow it to do that. Once it is done, then you can perform read-write operations. Similarly, once the data is returned, it again goes back to the ALB, and then the ALB sends this information back to the caller. Now, this is a typical Fargate-based microservice setup where your load balancer is using an ACM certificate over here, as well as behind the scene, the overall business sits within the task in the Fargate itself. Now, let's look into the third flavor of the same ECS Fargate, where you want to take the benefits of having a API gateway that allows all the requests to go through one single interface. And behind the scene, you want scaling of a Fargate, which is different than the scaling of a Lambda. Now, in this, you have the similar setup where you have a client using a browser, making a call, or using any kind of client making a call to this Route 53. Now, this Route 53 again goes to an API gateway, resolves the DNS of API gateway. API gateway is using this central piece, which was again in Lambda-based microservice setup. You have the Lambda authorizer, where authorizer performs the checks on the token and any kind of intent validation that you want to do. You will have allow or deny policies coming back. Once the allow is there or deny is there, if there is a deny, it is a straight no from here. But if it is a allow, you allow the API gateway to fall through. Now, because this is a setup where you want to use a Fargate based application, so it will have to go through a VPC link into a private application load balancer. From application load balancer, everything is similar to what you had in the Fargate based setup. Positive of this setup is that if you want to have a ALB behind an API gateway, where API gateway does the heavy lifting of providing a single contract or single interface for user to log in with a Lambda authorizer that can perform a interception of all the requests and provide you with the allow or deny policy. It's kind of a centrally managed service for you. So this can be handled by your central team while you can just work behind the scene of the business. In this case, the task receives the request, and based on the request, whether it is a request to query a RDS or perform any other operation on NoSQL database, it can perform all that info and then return it to the ALB, where the ALB sends a response to the API gateway and it is returned back to the user. This is a setup of Fargate-based microservice where API gateway is acting as a front door for all the requests that are coming in. Let's do some comparison between these. So I have this snapshot card. There are some important ones. So the cost model, the Lambda plus API gateway, you have paper invoke, which means milliseconds plus memory that is being used. It is going to be pricey if you're running 24/7. The Fargate and ALB, they are like dependent upon vCPU and per GB hour. The cost is also predictable based on the usage. So if you know the usage, it is better to go with the ECS Fargate. The third one, which is ECS Fargate, API Gateway, and the private ALB, you will have additional cost of having the API Gateway charges. The other charge will also be there for VPC link, which is hourly. If you look at the request limit, so if you're using API Gateway, the default is 29 seconds timeout, but now you can actually increase it to 3 minutes, I believe, if you want to do a custom timing. But primarily, by default, it is 29 seconds. ALB supports long-lived connections as well as WebSockets. So there is no hard 29 seconds cap in ECS Fargate and public ALB. The third one is again going to suffer from the same issue where your entry point is an API gateway. So you'll have a 29 seconds limit, but it can be increased to 3 minutes. Authorization, you can have a native Lambda authorizer, and which is a plus point where you want to have a central team manage all these authorization, or you have a central piece that manages that. In this, you have to write a custom library in the second one, ECS Fargate and public ELB. You'll have to write a custom library that can be run as a task. And the third one again can utilize the Lambda authorizer because it is also having API gateway. The TLS termination in case of Lambda API gateway, it's API gateway that handles over here. And then the ALB terminates TLS in this second case where the Fargate is with the public ALB. And the third one again, it is API gateway that terminates the TLS. When to use? For Lambda and API gateway, they are good for any kind of prototyping APIs, bursty request, or you want to do it for edge security needs. The ECS Fargate will be good for latency sensitive services, large framework, any kind of WebSocket requirements or chat, or you want to have some kind of customization around task. The third one is primarily hybrid approach where you need the container runtime, but you need the feature from API gateway. Like you can have throttling, you can use the centralized auth, API keys. You can pause the video and read through all of it. And I will also have the link to the blog. So you can always go and read it from there. Let's talk about some implementation notes and best practices. When you're using Lambda, you should prefer having small focused functions rather than one single monolith implementing all the endpoints, as I already mentioned. You should use provision capacity or concurrency for latency sensitive endpoints, which means if you have some endpoints that must be available, because by default you get 1,000 concurrent executions that you can perform for Lambda in each account. You should provide the provision concurrency so that important Lambdas that needs to be there, at least the numbers that are required or bare minimum required should be there. You can perform the cache-DB connections using various techniques, like you can have RDS proxy, or you can even have Redis having the caching around sensitive data. You can also use the environment variable and have the information stored, the keys stored in environment variable, while the information is stored in either secrets manager if they have to be kept as a secure data for secrets, and then you can have other parameters stored in parameter store. When using Fargate, you should keep the right CPU and memory for your task, and you should use auto scaling with sensible cooldowns. The second thing in Fargate is around keeping the container images. They should be lean, which means it should take lesser time to load the container. If they are too bulky or they have a lot more information applied to the images, then it is required to run the image. The container, it will take time to load in memory, and that will be slow. You can use multi-stage builds for packaging various kind of information in the container. The next one is health checks on the ELB so that when the load balancer is sending information to a task, the health check of the task is properly ensured. And in case of an issue, the container can be replaced. The last one is the IAM role. You should use task IAM roles and fine-grained security groups. And this is not only applicable for Fargate, this is applicable for everything in AWS or any other cloud. When using Fargate with API Gateway and VPC Link, you should keep your Lambda authorizer lightweight. This applies to the Lambda-based microservice also. You should have the monitoring in place for latency and concurrency. Thank you so much if you have watched till this point. I would look forward for your comments, your likes. Please do subscribe, share the video in case you find it useful. Let me know if you need any other information. I will try to make a video on that. Thank you so much.